It is so beautiful that studying something as big and vast as space always draws us back to appreciating nature and how the surroundings around us are so carefully crafted.
We are born explorers, we live explorers, and we live this world as explorers.
It's a privilege, truly, for all of us students to be exposed to such an environment where exploration is actually encouraged rather than suppressed.
I think the most important thing I advise anybody is to be as curious as you can be. I don't believe in failure, by the way. For me, failure, it's meaningless. I always call it the path to success.
What is something about the sun that would genuinely surprise most people?
We are born with that connection to the sun. It's really, we exist thanks to the sun. Science by nature, it's human. It's a collaborative. We don't call it competition. We call it collaboration.
What, according to you, is the biggest mystery in solar physics or heliophysics that continues to baffle the scientific community today?
If there is life out there, it's tragic. But if there is no life out there, it's also tragic.
What is one upcoming big discovery that is possibly going to happen that you think would absolutely shock the world?
That's the big question.
Hello everyone, welcome to another episode of the Shiv Nadar School Podcast. My name is Siddhi Kochar and I'm a student of grade 11 from the Noida campus. I'm really excited to be hosting the discussion today. The scientific study of the sun, known as heliophysics, involves not only just understanding how the sun works, but also trying to understand how it generates electricity and affects the rest of the solar system, including our very own planet. Today, we have the privilege of talking to someone who has dedicated their entire career trying to understand the sun. Dr. Nour Rawafi is a NASA astrophysicist and project scientist for the Parker Solar Probe mission, a mission designed to directly fly into the outer atmosphere of the sun, often described as humanity's attempt to touch the sun. Dr. Rawafi, thank you so much for being with us today.
Thank you so much for having me. It's really a pleasure being.
Sir, my first question to you is that you've worked so closely with the Parker Solar Probe mission, and you've worked with what I'm sure is a brilliant set of scientists for that mission. How was the overall experience working with such a team, and how was it to see the results of your work come to life in real time through the data sets?
Being involved in a mission of the scale of Parker Solar Probe, it's a very unique experience. It's probably one in a lifetime that will happen. And I would say, first of all, I see it as a privilege to be working with some of the brightest minds in the world from all over the globe. They are all working with the same goal, with the same objectives, and to achieve a big success like we've done with Parker Solar Probe. It's really amazing, and I would say the science and the technology that are involved in the mission are basically out of this world, if I would say. I mean, it's edge-cutting technology that allows us to build this spacecraft and to fly it so close to the sun with brilliant success. But the most important aspect for me, it's really the team. It's the team that is the heart of the mission that drives everything. And if the success, it really belongs to everybody who has been involved in it.
Sir, I definitely resonate with what you said. And to an observer, it all seems quite fictitious that we're even able to use science to achieve such feats. And so I wanted to ask that for most of us, the sun has always been this constant around us. It rises and it sets and it simply exists around us. But you've spent so much time studying it up close. What is something about the sun that would genuinely surprise most people?
I think the most surprising thing is, as you alluded to it, it's really our intimate connection to the sun. And surprisingly, most of us do not even realize that. Myself included, I study the sun for a living. There is not a single day in my life I don't think about the sun. When I wake up in the morning, I think about my family, the Parker Solar Probe, the sun, and things like that. But there was one day in particular that my son, back then he was, I think, 4 years old or something like that. So I was getting him ready to drive him to school, and he usually is a very cheerful guy. But that day he was standing by the glass door, and he was not really feeling, as usual. So I walked to him and I asked him, Adam, what's wrong? You don't look happy. And he told me, well, it's been raining. And in truth, it's been raining for 3 days. And And I asked him, what would make you happy? And without hesitating even for a second, he told me sunlight. To me, he made me realize that we are born with that connection to the sun. It's really, we exist thanks to the sun. Without the sun, there wouldn't be enough life on Earth. But even after that, we stay connected to it throughout our lifetime. I mean, our life depends on it. Without it, there will be no photosynthesis. There will be no food. There is nothing we can grow. But on top of that, it gives us the good mood, being cheerful and all that. It's really part of us. We belong to the sun. And I think somebody said, we are stardust. And it's true. We are babies of the sun and stars in the universe.
That's actually so beautiful, and I love this line that we are all in fact made of stardust, because it feels as though we're a part of the universe and as though we're a part of something bigger. And so, sir, I was wondering that although that we have achieved such incredible feats in the field of science, there is still so much more to know about the sun, and we only know what is perhaps a fraction of what there is to know. How much more do you think that we can expand our knowledge about the sun? And also, how do scientists such as yourself continue to remain curious about this field even after years of intellectually demanding studying and working on these fields?
I think the fascinating thing about science, there is no end to it. And as you just said, what we know is really very, very little from what we don't know. And if you take any scientist out there, myself, I personally feel it personally. I always see myself like ignorant. I'm basically almost don't know anything. Although when you come back to it, yeah, there are things I know, but you always look forward. There are so many big things we are curious about and we want to know about. So you set for yourself goals, but the nice thing about it, these goals are not fixed in time. It's always a moving target. Your target now is this cup. Once you reach it, no, it's not. It's no longer here. It's over there now, and that's actually the beauty of science. So that's what keeps us going about the sun, about the universe, even everyday life. It's something that is in us. It's born with us. If you think of it, actually, we are born as explorers from a very young age, as babies. We are so curious to know about things around us. I mean, when you put a baby in a room, they will start crawling, trying to discover, trying to touch things. That's actually curiosity that is born with us. And actually we live through it. I mean, we are born explorers, we live explorers, and we live this world as explorers.
Sir, it is so fascinating for me to see how curiosity has led us to such amazing achievements in the field of science. Do you think that we've gone from like the geocentric model to the neocentric model, and we've had such great scientists from Galileo to Kepler to Newton, and now modern day scientists such as yourself? It is amazing to think what simply posing the right questions can get us. And so I wanted to know that, coming back to the Parker Solar Probe mission, what was the big scientific question behind that mission that led scientists to say that, yes, we do need to explore the sun to this high degree of proximity and be this close to the sun?
For decades now, there are phenomena that we observe on the sun, in the atmosphere of the sun, that are defying any attempt for explanation. We have been observing the sun from afar, from around the Earth, for decades. And the number of attempts of scientists who tried to understand this phenomena, they all basically did not come to fruition simply because we did not have the data that we need to do it. And I give you just one or two examples of this. If you take the solar corona that we see during a total solar eclipse, it's a very tenuous atmosphere of the sun. But what is surprising about it, it is over 300 times hotter than the solar surface. We know that all the energy is coming from the interior of the sun, but surprisingly, when you move out a very short distance, the temperature of the gas will jump to multi-million degrees, where the temperature of the surface itself is only 6,000 degrees Celsius. And that is so mind-boggling. It's counterintuitive. From everyday experience, if this is a heat source, if you move away from it, it cools down. But for the sun, that does not work. And another other related phenomena to it, when the sun is a magnetized star, it's very active. And whenever there are these big explosions like flare and coronal mass ejections they occur on the sun, they are thrown magnetized balls of gas out there in the heliosphere, and some of them actually they come our way. And if just to give one example of their effect, I think 2 years or 3 years ago, SpaceX lost 40 satellites.
Oh.
And they were simply the result of an event that occurred, an explosion on the sun that hit the Earth atmosphere and caused disturbances. And all those satellites deorbited and then they burned in the Earth atmosphere. That's one of the examples. So the sun, as we said earlier, we owe our existence to it. But also it can be harmful in some ways, in particular to humans out there in space, to technology, now that we depend so much on space technology for GPS, for telecommunication, for internet. I mean, space is growing like never before. So we have to be so conscious about what the sun does and try to predict it, what it does at any time, and what is the impact on our atmosphere and our assets out there. And that's why we need to understand the sun. And in order to understand it, we need to explain these phenomena that are so complex. And some of them, we cannot understand them by observing the sun from afar. So we need to get closer. And you cannot believe it that scientists have been thinking about mission like Parker Solar Probe since 1958. I was not even born at that time, which is fine. It took us 60 years to do this mission.
It's an incredible feat to see how this sort of web of interconnected concepts manifests itself into missions like the Parker Solar Probe mission. And we're able to see the effects of understanding the sun better already in our surroundings, as you mentioned, the example of SpaceX. But sir, with an ever-changing globalized world where technology is at the helm of this globalization, and we talk so much about artificial intelligence coming into different fields. How do you think that the work that you do will be impacted by artificial intelligence, and what should students of today's time be aware of its effects so that we can sort of brace for impact if there's any negative impact of that?
Well, like anything in life, there are always dual uses for it. I mean, artificial intelligence is here. We cannot. There are so many things we cannot do without artificial intelligence. We are going to rely on it more and more going into the future. But also, we have to be conscious not to deviate from the good uses of artificial intelligence. When it comes to space, any mission we put out there, the amount of science data that returns to us, it's huge. It's huge. And using the old methods to analyze all this data, I mean, we analyze a tiny bit of it. So now with artificial intelligence, we will have the ability to analyze much bigger volumes of data and getting more information out of them. So for us, artificial intelligence is going to be a big help. It's going to help us to find things that we will not, even if we spent a lifetime looking at those data, probably will not have the time to look at all of it. But with artificial intelligence, we can actually go through large volumes of data and try to learn as much as possible out of them.
That's going to be an amazing revolution in the field of science in general, I believe. But sir, as you mentioned that the sun is such a vast subject where there is so much to uncover and so much data to go through and sort of sift through. How does one begin posing the right questions in such a vast topic? Because there's only so much that we can study. How does the initial process of the research look like?
Like any field of science, the unknowns are way more numerous than the knowns. And basically, whatever question you ask is a pertinent question when it comes to phenomena occurring on the sun or on our ocean or elsewhere in the universe. So the amount of information we need and the amount of science questions out there that we need to answer are so, I mean, it's so out of this world. It's mind-boggling. So whatever question you ask is a pertinent question. And going back to kids, I love to interact with kids. When I go to schools and talk to third, fourth, fifth graders, sometimes they ask you questions. They are so complex. And I mean, obviously, sometimes it's impossible to answer them because these are so fundamental questions. But the puzzling thing is how these young folks come up with these questions. It goes back to our nature. Humans are inquisitive from the get-go. They kind of find their ways to say, yeah, I see that thing. Can you tell me about it? So it's actually born with us.
So you talked about how humans are inquisitive, curious creatures by nature, and I think that's really beautiful. And all of that has led to many aspects of science manifesting themselves in our daily surroundings. How is one way by which solar activity has affected modern day life that people are still unaware of?
Well, I think the most impact it comes from what we call space weather. When we have this activity, magnetic activity on the sun, it's gonna impact us big time if we don't understand it. And the reason for this, if you look at SpaceX now, they are launching satellites by the thousands. Now I think they have something like 7,000 or 8,000 satellites orbiting the Earth just for internet and for communications. They are planning to launch tens of thousands. Imagine after that India will have their own constellation, China will have their own constellation, Europe will do the same thing. So that environment is going to be pretty crowded. And the issue with that is we want to avoid collisions by any means. Because if you have a collision between two satellites, what it will create a domino effect. You will have so much debris, and that debris will be flying all over the place. It will be hitting other spacecrafts, and basically it will be chaos. And that environment will be potentially not usable anymore. In order to prevent that, we need to predict space weather like we predict the Earth weather. What the sun is launching toward us, what the impact on the Earth atmosphere, we need to understand it way better than we do now. And we are not at that point yet. That's really a big focus now it's basically international focus. All nations are trying to focus on that. And that's really a priority. Again, why if everybody wants to have a handle on that? Because a huge part of our economy is going to be run from space. There is a study that was done a few years ago by scientists in the UK. They predict that by 2035, the space economy will grow to between $2 to $3 trillion. I think if they update that study now, that number will be much higher.
Much larger. Yeah.
So, in a way, our economy is going to rely on space more than ever before. And that's why we have to be really conscious of what is going on out there. In particular, how to live in harmony with our star, the sun. That's a high priority now.
That's a really interesting perspective, sir. And I think with the growing impact of space physics on the economy, what is also emphasized is global competition amongst countries, I'm sure. You mentioned how different countries will soon have their own constellation. That's such a baffling thought to even think about. So, sir, according to you, do you think that this sort of international approach to science is exacerbating the developments that we come up with, or is a globalized world a better approach to going towards scientific discovery? Because one could argue that when we have individual countries fighting in a sort of space race, like we saw in the 20th century space race, we could argue that it exacerbates the competition and drives innovation faster. But one could also argue that interacting with different perspectives has led to scientific discovery. So what are your thoughts on that?
Actually, for science, it's probably one of the best careers one can have, because we don't call it competition, we call it collaboration. And it's fascinating that we built Parker Solar Probe in the US. It's a NASA mission. But you have scientists from all over the world working on it. And we work together, we collaborate. I mean, we know each other, and we do science together. For example, India, they launched Aditya L1.
Yeah.
I was not involved in mission, but I used that data. Science by nature, it's human. It's a collaborative thing. I can tell you, I wrote science papers, and there was one co-author in particular in one paper. I never met that guy. But we still worked together, and we published that paper together. Well, I met him years after that, But when we were working on that, I know that he has expertise and we exchange information, but we were talking, but we never met in person. So that's actually the nature of science. Yeah, there is competition, but it's more on the collaboration side than anything. So science is global by nature, and it will remain that way.
I definitely agree with what you said, sir. And in fact, you started by saying that science you feel is the best field for a person to work in. I definitely agree with that. And so I wanted to shift the conversation now to more of a student's perspective.
Yeah.
For students who are deeply interested by the field of heliophysics and astrophysics, but don't yet have a starting point, what advice would you give them on getting started and how they can make their school life meaningful towards pursuing a career in that subject?
Yeah. I think the best thing I would say, whether you are interested in space physics, in cosmology, in particle physics, whatever field you are interested in, I think the most important thing I advise anybody is to be as curious as you can be, and you can be as ambitious as you can be. Ambition is something that you need to drive yourself. Without ambitions, you basically will stay in the same place. And the other thing, your horizons must be always moving ahead of you. Mm, in a way, if I say it, probably it's not the proper way to say it. What should never ever be satisfied with the achievement they reach. And actually, you will see it in yourself. You will see, yeah, I'm always at zero. I haven't progressed as I should, but in reality, it's not because your ambition is always driving you ahead of you. The other thing too, and this is really an advice from the heart, and I always say it to whoever should never ever let others set prospects for you. That's your duty. If you let others drive your future, you will go nowhere. You will start low and you will stay low. But when you drive them yourself, you set your own path. And if I give another one, is one should never ever be afraid of being wrong.
That's beautiful, sir.
Actually, and some people call it failure. I don't believe in failure, by the way. For me, failure it's meaningless. I always call it the path to success. If something doesn't work, it does not mean that you are not good. It just that experiment failed, and you have to do it in a different way to work.
I definitely agree with that, sir. And you said that ambition is such an important component in the recipe of getting to where you want to be in life. And so I was wondering, sir, where did that ambition start for you? When did you realize that you were passionate about this entire field and that you wanted to go into this subject?
I mean, I might surprise you. Actually, I was never ever interested in space and astrophysics. No, I was not.
Okay.
Actually, when I was an undergrad, my interest was in particle physics, quantum mechanics, and optical physics. And I applied to universities. Wherever I applied, I got accepted in all these fields. There was one university I submitted an application to do astrophysics. After the deadline, they still accepted me. I think they accepted me because I was the top in physics and all that. So probably that's why. So that was really the last thing I did, and that's where I went. And I wouldn't regret it 1 minute. I'm so happy with it. Coming back to the ambition, some of it is probably innate. It's born with us. It comes with us. But some of it, we learn it very, very early on. And the people we learn it best from are the mother and the father. The parents are the best teacher you can ever have. They will teach you things, even by observing them, that nobody else can give you.
Yes, sir. What you're saying really resonates with me because for us as students, I think it is so incredibly important that we have an intellectually stimulating environment, whether we're at home or at school, because indubitably our surroundings are what are going to put this will to explore the vagaries and the mysteries of the universe in our mind. And so Coming back, you said that you love interacting to children because of the very puzzling questions and deep intellectual questions that they ask. I was wondering if you could give us an example of a question that stuck with you that someone might have asked.
Uh, there are so many of them, and it's probably I will always go to my son, and he's the guy who always, you know, when he started asking question, he never stops. So it's. I believe I mentioned it yesterday morning. His favorite question is, "Daddy, why do you love space?" And actually, it took me really time to understand what he meant by it. So I think it all started with one evening I was preparing for a talk, and I was doing some movies about the sun and about planets, and actually he came to me and he laid his head on my shoulder, and he stayed there for a long time, and I realized he was there, but he was just watching. And after that, I turned to him. I said, "Adam, what do you think?" He just, "It's amazing." And after that, every time he came back to me saying, "Daddy, why do you love space?" It took me time to understand. Basically, he was asking for more. Show me more. Show me more. And kids, if you will, it's like they are like a dry sponge. The more water you give them, it will take it. So
I think fostering that curiosity in
Absolutely.
children is so incredibly important, and the environment that they surround themselves by affects that by a lot. And so you mentioned that you've given a lot of talks, a lot of discussions that you've been to. So I was wondering that what is one question that you always wished was proposed to you but hasn't been yet, so that I could ask that later on.
I think it's really hard to think of a question that was not asked to me, but it's probably I believe I was asked this and saying, well, if you go back, would you change anything in your path or something like that? And
Okay. So my next question, sir, is that if you could go back, could you change anything in your life, or if you had to give your younger self a piece of advice, what would you tell him?
probably I wouldn't change anything to the path I took. The path itself. I think the one thing I probably would change is how I approached things. I would have worked harder. That's definite. I would have worked harder. That's for sure. I'm pretty sure of that. But the other thing too is be more assertive and more confident. By nature, I'm pretty confident, but I would be probably more, because the more you are sure of yourself, actually the further you go, and that's extremely important. Having that self-awareness of your capabilities is extremely important.
I love that. That is really insightful, sir. And I think a lot of what you're saying is so much that we should learn from. And I've taken tons of mental notes, and I'm sure that the listeners have as well. So my next question is that we live in a world where we thrive on unpredictability, where things are changing now faster than ever. So, what is one upcoming big discovery that is possibly going to happen in the next 10 to 20 years that you think would absolutely shock the world?
There are many of them. I think one that is extremely important, if we even if we discover there is organic chemistry occurring elsewhere in the solar system that might be the source of life. Basically discovering either the source of life, future life, or existing life, or even past life on other planets or other moons in the solar system, or the universe out there. I think that will be mind-boggling. I think that's probably would be unparalleled discovery, because it's simply going back to our origins. We are always wondering if we are the only life form in this universe. And I think probably it's Carl Sagan who said it. He said, if
Look at this
If
little dot. Are you talking about?
yeah, and he had another saying, which is really he said it really well. He said, "If there is life out there, it's tragic. But if there is no life out there, it's also tragic."
Mm-hmm.
So either way, if we are the exception, why we are the exception? But if we are not the exception, we need to find out. I think that's one thing. The other thing too that is, I think it's extremely important, and you will hear about it. Maybe you heard about it. You know, the theory of general relativity and the quantum mechanics are one of the two best theories that we came up with for in the last century or so. But now we are reaching some limits where we cannot explain things. Maybe in particular with gravity, extremely hard when you want to quantize it, when you want to merge the two theories together, everything breaks down. So there is something missing. And I always predict it takes probably about a century to a century and a half when people make huge breakthroughs to start a new theory. And we are at about that time because the general theory was discovered about 100 years ago, a century ago. Quantum mechanics also started about that time as well. It's probably time to make another big leap forward. And again, to you and to everybody out there, you guys have the best chance to do that.
Sir, the sheer potential of science is so exciting for us students because it's very reassuring to know that there is so much left to uncover and so much left to discover. And so I was wondering, sir, that if a student in grade 9 or 10 of high school wanted to follow a path similar to yours, what advice would you give them, or what sort of rule book should they follow?
First of all, I will advise them. They have to find their own path. They should not follow any other path. I mean, everybody, they have their own path. They have their own abilities. They have their own ambitions. They have their own way of doing things. I think it comes back to believe in yourself. Be ambitious like hell.
That's a really important thing to do, to believe in yourself and to have that self-belief. We also spoke a little bit about how mysterious all of it seems. You talked about how one theory begins to disprove another and how there are so many contradictions in the field of science. What, according to you, is the biggest mystery in solar physics or heliophysics that continues to baffle the scientific community today?
Well, there are so many of them. I mean, we talked about the coronal heating, the solar wind, solar activity, but even when you go to the structure of a star, like our sun, and how the magnetic activity occurs within the interior of the sun. Now we have what we call the solar cycle, that is every 11 years. That one was discovered by something like 300 years ago, and to this day we don't really understand how the solar cycle comes by, why the magnetic activity is cyclic on the sun. And this is, by the way, it's not unique to the sun. You see it also on other stars out there. That's something so puzzling. If I go even further, it's something I'm continue reading about. There is what we call dark matter, dark energy, black holes. All of these are objects out there, and they defy understanding, if you will, where physics breaks. When you get on the horizons of a black hole, the physics we have now doesn't work anymore. And that's actually where the problem is. That's actually where we have to invent a new physics. When you look out there, let me take the example of dark matter. When you look at galaxies, obviously when close to the nucleus, stars are rotating so fast. And that's obvious. They have to. It's like the inner planets in the solar system. They rotate so fast around the sun. The outer planets are much slower. But when you look at galaxies, stars much further out from the nucleus are supposed to rotate slower, but they are not. The speed of the rotation of stars, they rotate basically at the same speed. And if we take the current theories we have, these stars should not remain on those orbits. They should be ejected out. So that's actually where the main idea of dark matter came from. So there must be other matters that keeps them glued to the galaxy. What is that matter? That's the big question. We don't know.
I think it's so poetic that we as people search for the problems to then come to the solutions of the world that surrounds us. Dark matter and dark energy are concepts that we are just exposed to, but we truly know nothing about. And that potential of exploration is very, very exciting for all of us. Sir, my final question to you for today is that you spent your life exploring our solar system, how the sun works. What has that told you about life back here on Earth? Or what is one takeaway from space exploration that you can bring to life back here on Earth?
For here on Earth, or for out there in the universe, if we look for life, we always need the star to start with, and after that you have to look for planets and look for the right conditions to be in it. The thing I would say, we are so privileged and so lucky to be on a planet like ours, to be exactly in the right place in the solar system where life can thrive. It's really mind-boggling. It's because if Earth gets a little closer, it will be too hot. If it goes a little bit further out, it will be too cold. It will not happen. And here we are. We are so minuscule on the scale of a star like the sun, and even more on the scale of the galaxy and the universe. But we are the most intelligent creatures that ever existed. We can make sense of things that we will never ever touch, that are at the edge of the universe, and we still get some understanding into them.
So I think it is so beautiful that studying something as big and vast as space always draws us back to appreciating nature and how the surroundings around us are so carefully crafted to support our living. And it really makes all of us appreciate the act of living and the act of being able to pursue scientific exploration. It's a privilege, truly, for all of us students to be exposed to such an environment where exploration is actually encouraged rather than suppressed.
Absolutely. So coming, you're absolutely right. And coming back to that feeling, being the exception, we have to make the most of it.
Absolutely.
And I think that's probably the message I would give to anybody out there. Yeah, we are the most intelligent creature that we know of. And we best exploit that, make use of it.
Thank you so much for this discussion, sir. It was really insightful. I learned a lot of things and I cannot wait to implement my learnings into the real world.
It's a real pleasure talking to you. Yeah, thank you.
Thank you so much. See you next time.